Okay, lastly, we have probability problems that are going to be a little bit more difficult. They're called compound events, and that's when the probability needs to be found for two or more simple events. For example, it's like flipping a coin and then flipping a coin again. We've got independent events, and independent events are when the outcomes of one event does not affect the outcome of the other. For example, like flipping a coin. If you flip a coin and it lands on heads, that doesn't mean you're more likely to land on heads or tails the second time. It's just completely independent. There's always a 50-50 chance. Same thing with rolling dice. It's always independent of the other. You're never gonna, have a more probability of rolling a 2 if you didn't roll a 2 before. Spinning a spinner, as long as all of the numbers are still there or all of the different things on the spinner are still there, each thing is independent of each other. When we are finding the probability of these compound events, like flipping a coin at landing on heads, spinning a spinner at landing on the number 10, what you do is you just find the probability of each one and then you just multiply them. So it's pretty simple. So for example, what is the probability of rolling a standard die twice and getting an even number and then a 5? So it might be helpful for you to just think about the sample space of a standard die, which is the numbers 1, 2, 3, 4, 5, and 6. That's our sample space. The probability of rolling it twice and getting an even number first. So there's 1, 2, 3 out of 6 even numbers. You could use 3, 6, or you can use 1/2, doesn't matter. And then rolling a 5, there's 1 5 out of total 6 numbers, so we would multiply these. And then in your calculator, multiply them out, simplify it. 336 is what we would get, but we would want to simplify that down to 1/12. What is the probability of tossing a coin three times and getting tails each time? Well, the probability of getting tails the first time is 1/2. The probability of getting tails the second is 1/2. The probability of getting tails the third time is 1/2. So the probability of this would be 1/8. Next, we have a spinner that's spun once. Find each probability. So we've got 2 different spinners here. The probability of the first one being 11. So out of 12 total numbers, one of them is the number 11. So the probability of that happening is 1/12. And then looking at the second spinner, there's 2 different parts of it that are red out of 5 total parts of the spinner you can land on. So you would multiply 1/12 times 2/5. That would be 2/60. But we always simplify our final answers. That would be 1/30 in the end. The probability of it being unshaded and then landing on green. So unshaded, just count out how many there are. There's 8 that are not shaded in out of 12. And I usually never simplify my fractions. I just use exactly the fraction that it is, because in the end you have to simplify, so there's kind of no point to simplify it right now anyway. So 8/12 times, and then green, there are 2 out of 5 that are green. Multiply it out, you get 16/60. That simplifies down to being 4/15. The probability of landing on at least 3, so that includes 3. At least 3 means 3 and above. There are 10 numbers that are at least 3 out of 12. And then landing on blue, there's 1 blue out of 5. So you multiply 10/12 times 1/5, you'll get 10/60, and that simplifies to be 1/6. And then the probability of it landing on an even and shaded. So the even that are shaded would be 2 and 8. So there's only 2 of them. 2 out of 12. And then not red would be any color but red. There's 3 that are not red on that spinner. That would equal 6/60. 1/10 would be our final answer. Sometimes questions like to talk about cards randomly selected from a standard deck of cards. You do actually have to know this if this type of question were to pop up, that there are 52 cards in a deck. There are 4 different suits So we've got the hearts, diamonds, clovers, and spades. Or wait, the 4 suits. Spades, hearts, diamonds, and clubs. Yeah, I was right. So you need to know that, and there's 13 of each type. Meaning like there's like 13 heart cards and so on. Okay, so a card is randomly drawn from a standard deck. Then a date in the month of June is chosen at random. Find the probability of this different stuff happening. So this one requires you to know a couple of things too. You need to know that June has 30 days. So the probability of it being an ace, well, there are 4 aces in a standard deck out of 52. And then an odd number of June, so there's 30 numbers in June, 15, half of it, 15 will be odd. So we would multiply this together, and you're gonna expect to see some weird answers sometimes with probability. When you multiply this out, it would be 60 over 1,560, and that's 1/26 as our final answer when we simplify it. The probability of the card being chosen is a spade. That would be 13. There's 13 spades out of 52 total cards. And then a multiple of 4 out of the dates of June. So the multiples of 4 would be 4, like June 4th, June 8th, June 12th, 16th, 20th, 24th, and 28th. That's 1, 2, 3, 4, 5, 6, 7 numbers are multiples of 4 in June. So 7 out of 30. And that would be 91 over 1,560, which simplifies down to 7 over 120. Now we could continue on and do like a million more practice problems, but that's basically how independent probability works. We also have dependent probability. So dependent probability is a little bit different than independent because what happens the first time does affect what happens the second time. You still find the dependent probability by multiplying the 2 events together, but what happens here is usually the denominator is going to change because this is going to be a type of situation where it's not a spinner anymore. Maybe you have like everybody in class's names in a hat and you're selecting one person at random, and then you go into the hat and you select another person. The number of people's names in that hat are going to decrease every time you put your hand in there and select one because you're not putting it back in, so you're not replacing it. A lot of times the questions will say like without replacement. That means it's going to be this type dependent because it's going to change. So when looking at these types of questions, like number 7, there are 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a pencil box. A marker is drawn, not replaced, and then another marker is drawn. Find the probability. So first we have to figure out how many total there are. So count it all up, and we have 25 total markers. So the first time we select one, there's going to be a total of 25. So I can see from the description there are 4 reds, so the probability of being red then blue. There are 4 reds to start out of the 25. But then because we are not replacing the first one that we're taking out, the denominator is going to decrease from 25 total markers down to 24. It does not decrease by 4 markers. It's only decreasing by 1 because we are only selecting one marker, taking it out, not putting it back in, and then selecting a second marker. So we only decrease the total by 1 because only 1 is being taken out. But the probability of it being red the first time is 4 out of 25 because there are 4 markers in there that are red. And then for blue, we've got 12 that are blue, and that second time you put your hand in there, there would only be 24 left over. So then you would multiply this, and again, you'll expect to see some weird answers here. 48 over 600 simplifies to be 2 over 25 as the final answer. The probability of selecting yellow, not replacing it, then green. So there's 6 yellow out of the total to start again, 25. And then green, there are 3, and the denominator will decrease to 24. Multiply these out, 18 over 600 simplifies down to 3 over 100. Now here are the interesting ones. The probability of them both being blue. You still have to think of it as the first time selecting blue. So out of the 25 total to start, 12 of them are blue, but here's what happens. That second time you go to reach your hand in there to select a second blue marker, there's only going to be 24 total markers left, but we actually also have to decrease the blue number of markers as well by 1, because if you're selecting a blue marker from 12, there's only then 11 left over inside the hat. So we would have to multiply 12 25ths by 11 24ths. That's 132 over 600. That simplifies down to 11 over 50. Similarly, if we do that with yellow, to start, we have got 25 markers, and 6 of them are yellow to start. If I take that yellow out that I select, and I don't put it back in, there are only 5 that are yellow left inside out of 24. So we multiply 6 25ths by 5 24ths. We get 30 over 600, and that simplifies down to 1/20. So that's how dependent probability works. And again, we've got more practice problems here, but what happens is just the denominators are going to change, and sometimes the numerators too, depending on the situation.